All right, today we're going to continue talking about solving equations, rational equations with fractions in them. All right, but we're going to be doing application problems. And there's about 3 types of problems they're going to put some in this lesson. They're going to put mixture problems, and your formula that you need is that the milliliters of pure acid over the milliliters of the mixture has to equal the concentration of the acid. When you're trying to minimize a perimeter of a rectangle, the formula is 2 times length plus 2 times the width, okay, where x equals the width in meters. And if you're talking about cans, and they're going to be talking about 2 things. They're going to be talking about volume and surface area. What they're going to do, they're going to basically give you what the surface area of a can is and what the volume of a can is. And they want you to figure out what the radius and the height are. So your plan is going to be to solve this first equation for H, I guess, or you could do R. But I would solve this one for H, plug it into this H, and then simplify that as far as you can and solve it for R. Then plug in R here, just like we would a system, and figure out the radius. Alright, so it says how much pure acid must be added to 50 milliliters of a 35% acid solution to produce a mixture that is 75% acid. Okay, this is the concentration of the acid, so that's going to go there. The milliliters of the pure acid, all you do is you already have 50 milliliters of this kind of solution. So to figure out the pure acid in that, you take the 50 milliliters times the percentage, which is 0.35, and that gives you, if you multiply 17.5, and that's what's that's what's in there, but you're going to add to that, and I don't know how much pure acid I'm going to add to that. So there's my pure acid, 17.5 plus x, or you could put x plus 17.5, doesn't matter. The milliliters of the mixture, well, you already have 50 milliliters there. Again, you're going to add x to it, so there's my milliliters of the mixture. So if you put all that together, on top I have x plus 17.5 over x plus 50 has to equal 0.75, because it's got to equal the concentration of the acid. So now if I solve this, I'm going to multiply both sides by x plus 50. Gets rid of that, gives me x plus 17.5 equals, distribute, I get 0.75x plus 37.5. So now I've got to get my x alone. So I'm going to minus 0.75x minus 0.75x. That's going to give me 0.25x plus 17.5 equals 37.5. Subtract 17.5. I get 0.25x equals 20. Divide by 0.25, and x equals 80. So we should add 80 milliliters of pure acid to the 50 milliliters of 35% acid to produce a mixture that's 75% acid. Okay? Alright, and I animated that. And graphically, if you typed in this for y1, x plus 17.5 over x plus 50, and you typed in 0.75 for y2, there's the 0.75 horizontal line. There's that boomerang looking thing, and you can tell they intersect at 80. Okay, so this one says find the dimensions of a rectangle with minimum perimeter if its area is 200 square meters. And then they want me to find that least perimeter. So what we have is this picture, okay? And what it tells me is that the area is 200. I don't know the width, but if the area is equal to the length times the width, then, and I know the area is 200, and I don't know the length, but I know the width is W. To figure out this length up here, I would get L alone. So divide by W, and that's where they're coming up with this 200 over X for the length. So now, if I set that up, so I would set up my area equals my X times 200 over X. Okay. There's my area of my, well, it'd be 200 over X times X, but it doesn't matter. There's the area of my perimeter. Okay. Now to get, the area of my rectangle. Now to get my perimeter, okay, it's going to be 2 lengths, which was 2 of these, plus 2 widths, which is going to be 2 of these. So we call that X. Okay. And now, I could simplify this. This would be 400 over X plus 2X. Now, I'm not going to solve this. And if I did, actually, if I multiplied by X and solved it, it'd be a quadratic, and I could simplify it, and I'm going to get imaginary roots. And that the reason is because there are no zeros. Okay? Let me get a picture for you. So if I type this into my graphing calculator, I get this picture, and obviously I had to adjust my window. I went from 0 to 50 and 0 to 150 on the Y's. Okay, and again, you can see it doesn't cross the x-axis, so solving this would do no good. Plus, that's not what they're asking for anyway. They don't want solutions. They want a minimum. They want a value of x that would produce the minimum perimeter. So if I calculate minimum on my picture, I get 14.14, 56.57. Okay, so my minimum value of x, which is my width, would be 14. And it doesn't tell me what to round to, so let's call it 14 point, let's just round to 1. So if my width was 14.1, then my length would be whatever 200 divided by 14.1 is. And I don't have my calculator over here, so whatever that would be your length. You just have to type that in the calculator and get a decimal equivalent. Okay? Alright, so now we have this Stewart Cannery packages tomato juice in 2-liter cylindrical cans. Since 1 liter equals 1,000 centimeters cubed, which they just expected you to remember, and if you didn't, I just reminded you. Okay, so if a 1 liter can has a volume of 1,000 centimeters cubed, if it's a 2 liter can multiplied by 2, you got a volume of 2,000 centimeters cubed. And they want you to find the radius and the height of the cans if the cans have a surface area of 1,000 centimeters squared. So the two things that they're telling me is that 1, the volume of a can is 2,000 centimeters cubed. And the other thing they're telling me is that the surface area is 1,000 centimeters squared. So I take my volume formula, which again they expect you to remember, and my surface area formula, which they expect you to remember, and I'm going to plug in my values. I know the volume, and I know the surface area, so I changed S to 1,000 and B to 2,000. And now I have a system of equations. So I'm going to solve the first one for H and then substitute it into the surface area one. So if I get H alone here, I'm going to divide by pi r squared. And that would give me my H equals 2,000 over pi r squared. So now I'm going to substitute that in over here. So I have 1,000 equals 2 pi r squared plus 2 pi times r times 2,000 over pi r squared. If I clean this up and simplify it as far as I can, this pi cancels this pi. One of these r's cancels that. And I have 1,000 equals 2 pi r squared plus 4,000, because I multiplied 2 times 2,000, over r. Okay, so now this is a third degree function. So if I'm going to solve, I mean, it'll be a third degree function if I multiplied through by r. Okay, I'm going to make an r cubed function. And you can do it, but at this point I know it's a third degree function. Algebra isn't going to work, so I need the graph. So if I graph it, okay, and I calculate the intersection points, and all I did was typed 1,000 in, there's the 1,000 line, and then I typed this side in, and you got this whoop-de-woo graphy thing going on here. And so if I calculate where they intersect, okay, this intersection point right here, I mean there's one over here, but a negative isn't going to make any sense, so that's extraneous. This 0 right here is at 4.6, and this intersection point right here is at 9.7. Okay, so I solved this thing for r. Yeah? Okay, so I've got my two values of r. Now I have to plug them in over here. My height is going to equal 2,000 over pi times 4.6 squared, or my height is going to equal 2,000 divided by pi times 9.7 squared. And if I do the math, okay, this comes out to 30.1, and this comes out to 6.8. So I could have the two possibilities, the two possible sizes of cans that would give me a surface area of 1,000 and a volume of 2,000. One would be a radius of 4.6 and a height of 30.1. And the second possible can would have a radius of 9.7 and only a height of 6.8. So those are my two possible cans that they could make. Okay? Alright. So now if we, and then I said found those, substitute into there and find the solutions. Okay, so a little bit of homework help. These ones you're just clearing fractions. So you'd multiply both sides by x squared minus 2. You'd have to factor this. It'd be x plus 4x minus 1. So you'd have to multiply everything by both. This one you just have to multiply everything by x. Or you could solve them on the calculator, type this side in for y1, this side in for y2, and calculate intersection points. Okay? If you find no sign changes, okay, that means that they don't intersect ever, and there would be no solution. And that's going to happen algebraically. If your answers that you get you have to throw out, because when you plug them back in you don't get true statements. Okay, and on the bottom one there were actually 3 intersection points, here, here, and here. But again, algebra would solve it just as well. Okay, so you've got another acid mixture. Okay, so if we do another one, just to kind of go through the process again. It says, and if you remember our statement, you have the pure over the mix equals the concentration. They want to, it says, suppose that X milliliters of pure acid are added to 100 milliliters of a 35% solution. Express the concentration of the new mixture as a function of X. Well, we have 100 milliliters of a 35% solution that we're going to add more to, and on bottom we have 100 milliliters that we're going to add X to. So on top I would have 100 times 0.35, which is 35, plus X over 100 plus X, and that would be A. For B, it says use a graph to determine how much pure acid should be added to the 35% solution to produce a new solution that is 75%. So they want that new solution to be worth 75%. So for C, they want me to solve for it algebraically. Okay, so if I did it algebraically, I would multiply by, B, I'm on B. Use a graph. So if I graphed it, okay, and I just wrote over all my junk. you can see that it crosses at 160 and 0.75, which says there should be 160 milliliters added. So we are going to now solve it algebraically. So if I had 35 plus x over 100 plus x equals 0.75, I'm going to multiply both sides by 100 plus x. That will cancel it. I get 35 plus x equals 75 plus 0.75x, distributive. Put x's on the same side. I'm going to subtract 0.75x minus 0.75x. I get 35 plus 0.25x equals 75. Minus 35 minus 35, 0.25x equals 40. Divide by 0.25, divide by 0.25, and x equals 160. And we got it. Alright, so breaking even. It says Midtown Sports Apparel Inc. has found that it needs to sell golf hats for $2.75 each in order to be competitive. If it costs $2.12 to produce each hat, and it has weekly overhead costs of $3,000. It says let x be the number of hats produced each week. Express the average cost. So we're talking about your cost function. Well, that's going to be, your cost function is your overhead plus the price to produce each hat. So that'd be plus 0.12 for each hat. Okay? That's your cost function. Now, for one hat, you'd have to divide it by x. This would be for all the hats you made. So if you only want for one hat, you have to divide by the number of hats you make. Now, B says, solve it algebraically to find the number of golf hats that must be sold each week to make a profit. Profit, you have to know, profit is your revenue, take away your cost. In other words, how much you make minus your cost. I'm going to make $2.75 per hat. So that's $2.75x. I have to subtract my cost function, which is up here without the dividing by x, because this is for all the hats. So 3,000 plus 2.12x. And that will be my profit. Okay, so if I clean this up, my profit function is going to be 2.75x minus 3,000 minus 2.12x. Combine like terms, and my profit is going to be 0.63x minus 3,000. Yes? And it says, oh, sorry, right up here. So now I'm going to solve this, I'm going to set it equal to 0. And I'm going to solve. So I'm going to add 3,000. And I get 3,000 equals 0.63x. Divide by 0.63. And I get x equals 4,761.9. So in order to make a profit, I would have to make 4,761, actually 4,762 hats. I will not make, and you can see right there is an intersection point. Okay. Alright, so now on D, or C, it says how many golf hats must be sold to make a profit of $1,000 in a week. So now what they're saying is take this same function and set it equal to 1,000. So I'd have 1,000 on this side equals 0.63x minus 3,000. And to solve it, I would add 3,000. And I would get 4,000 equals 0.63x. Divide by 0.63. And x equals 6,349.2. So to make a profit of $1,000, you'd have to make.
Good morning, everyone.
Hold on.
Great weekend. It was a great start to it on Friday night when our men and our coaches and our...
Okay, sorry, had the announcements real quick. All right, so you'd have to sell or make and sell 6,349.2 hats in order to make a profit of $1,000. Okay, and you can. Okay, sorry. Next one. Says the number of bears at any time t in years in a federal game reserve is given by this function. It says find the population of bears when the value of t is 10, 40, and 100. They're literally telling you to find p of 10, p of 40.
Eric Maldonado, Valerie Garza to the attendant's office. Eric Maldonado, Valerie Garza to the attendant's office.
Miss Abby, what a wonderful day.
Okay, so to find p of 10, I would plug in 10. So 500 plus 250 times 10 over 10 plus 0.5 times 10. Use a calculator and you're going to get 200. P of 40, plug in 40. 500 plus 250 times 40 over 10 plus 0.5 times 40 is 350. Shh. P of 100, plug in 100, 10 plus 0.5 times 100 is 425. Okay, so those are the values of the bear population at 10 years later, 40 years later, and 100 years later. So you can tell the bear population is increasing, which makes sense. That's what it shows. Okay, so B says, does the graph of the bear population have a horizontal asymptote? Well, my horizontal asymptote comes from my top degree, which is 1, my bottom degree, which is 1. So since it's a tie, my horizontal asymptote is at top leading coefficient divided by bottom leading coefficient, which gives me y equals 500. So this thing has a horizontal asymptote at 500.
Mark Maldonado to the attendant's office. Mark Maldonado to the attendant's office.
Sorry, and what that means is that the bear population...
Miguel Jose to the attendant's office.
What that means for the bear population is that it can't go past 500. Okay, so the largest the bear population can become is 500. Okay. Alright, so minimizing, we've got another minimizing perimeter. So we've got a rectangle that has a width of x. It says my area is 182, so since area is length times width, area is the length times, I call my width x, so my area, or my length, is going to be area over x, which is 182 over x. So there's my width, there's my length. Perimeter is 2 widths plus 2 lengths. Okay, if I clean that up, I get 2x plus 364 over x. Alright, and if you graph it and calculate the minimum, you'll get your solution. And it is right there. Again, we don't care about this side because the negatives don't make any sense anyway. So it's right there when x is 13.5 about. So my width would be 13.5 and my length would be 182 divided by 13.5, whatever that comes out to be. One more slide, guys. Alright, so we've got another of the canned ones. This time, the cannery will pack peaches in a half a liter can. Well, since 1 liter equals 1,000 centimeters cubed, then a half a liter is going to be half of that, which is going to be 500 centimeters cubed. So the volume of my can has to be 500 centimeters cubed, and they're telling me the surface area is 900. So if I replace volume with 500 on this side, pi r squared h, right? and I replace 900 for surface area on this side. Okay, I have two equations and two variables, so it's a system. So I'm going to solve one for one variable and plug it into the other. I'm going to solve this one for h, so I divide by pi r squared. So I'm going to replace my h with 500 over pi r squared. This pi cancels this pi, this r cancels that r, and I have 900 equals 2 pi r squared plus 1,000 over r. And I'm going to graph. I typed 9,000. Oh, crap. I typed in 9,000 and I should have only typed in 900. Oh, poop. Hold on. Somebody bring me a calculator real quick. Okay, so I fixed my mistake here, right? I don't know why I thought that it said 9,000, but so I changed y1 to 900. And I typed in the second one to be 2 pi x squared plus 1,000 over x. And I had to change my windows, so I've got some intersection points. It crosses here when x, which is talking about our radius, is 1.12, and it crosses here when our radius is 11.4. So if I substitute those back in over here to find my radius, I'm going to have 500, or my height, my 500 over pi times 1.12 squared. And then I have 500 over pi times 11.4 squared equals height. And if you type those in, you get 126.9 here and 1.2 here. So if you have a can that has a radius of 1.12, the height has to be 126.9 in order to get the right volume and surface area. If your radius is 1.2, why did I write 1.2 there? Oh, yeah. So your height would be 1.2. Sorry. If your radius is 11.4, then your height would be 1.2. Alright, so how do you solve equations involving fractions using graphical techniques? You do y1 for your left, y2 for your right, and you calculate intersection points. When solving a word problem, what clues indicate the need for rational expressions? Anytime you have division involved. Show an example of a problem, its extraneous solution, and why the solution is extraneous. So you could back up to this last one. Here's another solution. It's extraneous because if you calculated it would come up x equals negative something, and you can't have a negative radius or height, so it's extraneous. Alright, and we are at homework, so we are done. Happy homeworking, and I will see you next time.